Now, to see how this cognitive-based CPS model is realized, we will look at this testbed model. Cognitive agents were installed in a PC, in which each PC corresponds to a different machining process. So in this case, it is turning, drilling, and milling processes. Note that there are 3 agents that will work together for each machining process, which is the machine agent, the workpiece agent, and the transporter agent. So this system also has 3 PLC, one for each machining process, which serve as a controller in the physical system. It also has an RFID system, a transporter system which transfer the workpiece, and a manufacturing execution system. To see clearly how this actually works, we can look into the communication protocol inside this model. Okay. So the manufacturing execution system, or MES, communicates with cognitive agents through Ethernet converter devices. 3 switches were used as the devices that generate disturbances. Okay. An RFID system connected with PLC by RS232 cable was used for reading and writing the workpiece information. PLC connects to the PC through the Ethernet cable. The CPS also connected to other CPS through wireless connection. So in the normal case, the PLC activated the green light when the workpiece information was sent to the machine agent on the PC. And if the disturbance was input, that means turning on the switch, the red light and alarm were turned on. So in this case, the machine agent generates a new plan or cooperated with other machine agents in the system. So this is like the pictorial of what actually the system looks like and how the connection that we've seen here is connected to physical devices in the model. So the cyber pipe actually is handled by PC, okay, in which 3 independent agents. In the CPS model, the communication that we've seen just now is laid out in this diagram. We can see that the physical devices that serves as sensor, which is the RFID reader and switches, are connected directly to PLC that serve as a controller on the physical part of this model. And the cyber part is handled by PC, in which 3 independent agents for each PC that serve different purposes were interconnected to manufacturing execution system to decide on appropriate action for the PLC to execute. Okay. So if we take a look at the normal case here, when there is no disturbances, the operation sequence is turning, then drilling, then finally milling, which takes 3 minutes for each operation. So once there is a disturbance, the algorithm is updated with a new working mechanism which will be determined by the cognitive agents. So the cognitive agents will make decisions according to disturbance type and recovery method. Using perception of which disturbances happens, the cognitive agent will adjust the current working algorithm based on 3 recovery methods, which is non-negotiation, negotiation, and rescheduling. So in non-negotiation, the machine overcomes the disturbance by itself, which applicable to disturbances that require a short time to recover. Otherwise, the machine needs to cooperate with other machines to find the appropriate machine for carrying out its work or rescheduling. For negotiation among CPS to find out the appropriate CPS for carrying out the task, in this model, a pheromone value inspired from ant colony is applied to optimize the outcome. So this ant colony optimization algorithm is a collection of meta-heuristics inspired by ant colony, which aims to solve combinatorial optimization problems. So this optimization problems actually happens because for each of the CPS, it has its own variables. And then variables means like, what kind of machine tools or that they have connected to that CPS, and what kind of processes, process parameters that they have in the CPS itself. So that makes the combinatorial optimization problems. So we need this kind of meta-heuristics algorithm to actually solve them. Okay, so this flowchart explains how the decision making is done by the agent. We can see from here that the decision to either negotiate or reschedule will depend on recovery time. Okay, which is expected from the previous database of disturbance ID. If the recovery time took less than an hour, we will decide on whether it can be solved internally within that machine only, or it needs negotiation with other machines. If reactive plans exist for internal solution, we can use that solution and we can start machining. Otherwise, we will also need other machine to negotiate the solution. So from this flowchart, we know how important it is to have some sort of system governance that will overlook all the processes inside this CPS.